But we bring on our next speaker, who is another person pointing to the stars. We're just going to remove the table. Thank you, Martin. Do that so gracefully. Yeah, Gary Lai. He is one of the most renowned aerospace engineers, and he's also been a speaker here before. His presentation was incredible, so I'm so excited to see what's new and hear him speak again. But he actually led the team that designed a rocket. His rocket was called New Shepard, and he flew to space himself on that in April of 2022, making him the only lead designer of a rocket ever to fly to space. So this is truly revolutionary. He's now a co-founder of Interlune, where this initiative is going up there to mine on the moon. They're harvesting what is limited on Earth, but plentiful up there, and trying to tackle a sustainable future. Their current mission is to mine helium-3. So please welcome to the stage, Mr. Gary Lai. It's all yours.
Thank you, Tilly. I am very excited, very happy to be back in Prague. Like Tilly said, I was here 3 years ago, and so much has changed in the last 3 years, not only for the space industry, but for me personally. I'm very excited to give you an update, and for those of you who haven't heard it, to hopefully inspire you. So I want to start first with a little history, and by history I mean ancient history. So 12,000 years ago, the first major technological revolution occurred, the agricultural revolution. And humans learned how to farm the land, which means that they were able to settle and establish large cities and civilizations. In 1850, the Industrial Revolution occurred, and now humans were no longer bound by the power of animals or human beings. They could develop machines, use fossil fuels, and do large-scale development. And then in my lifetime, the Digital Revolution has emerged, and now humans are no longer bound by the information or the computation they can do in their heads or information stored in books. And instead, computers can do that computation and store that information much faster and in larger volumes. But I believe very firmly that we are on the cusp, and it's already started, of the fourth major technological revolution, and that is involving space, to where we will no longer be limited by the resources of Earth, but we can use the limitless resources in space to grow human society. It may sound like science fiction, but hopefully after this, I will have convinced you that it has started. So in the past, and this is even before the time that I'm talking about, space is already a big part of your lives. Did you look at the weather forecast today? Did you navigate to this location using your phone, using GPS? Did you use the internet? If you did all those things, you were using satellites. You were using the product of a $500 billion annual industry in space. And also at space, we've explored the farthest reaches of the solar system. There are people living in space, and now about a dozen people in various space stations. But this was really only the beginning. Here's a graph, the only little graph I'm going to have in this presentation. It shows the number of objects launched into space by year since the very first launch of Sputnik in 1957. And you can see, and this is number of objects, but I guarantee you the mass, the objects are actually getting higher in mass. So this is about the amount of mass that's being launched. And you can see that really for most of the history of space flight, there were about 100 to 200 objects launched into space. But what else do you notice? Something happened about 10 years ago, and it started to skyrocket. And what happened? Well, during most of that history, rockets were single-use devices. You had to throw them away. They were destroyed after each launch. Imagine how expensive it would be to take an aircraft flight, maybe across the ocean. You had to throw out the airplane afterwards. And not only that, about 2% of the time, the rocket blew up on the way to space. So what if you had a 1 in 50 chance of surviving the trip across the ocean? Would you ever go? Probably not. But that was what happened until about 10 years ago. We started to reuse the rockets, and they became much more reliable and much lower cost as a result. And I mean 10 times lower cost and 10 times greater reliability. Now, I had a part of that revolution. I led the team, as Tilly said, that developed the New Shepard rocket. You might have heard of New Shepard before. It's famous for flying some very prominent people. For example, Katy Perry flew on New Shepard. Captain Kirk William Shatner, 90 years old, flew on New Shepard. It was something designed to democratize space so that really anyone can go. Why Alice is going to train for 3 years for the human space flight. I trained for 3 days to fly on New Shepard. Now, it doesn't go nearly as far. The mission is relatively short. It's designed really for about 4 minutes of microgravity. There I am on the left-hand side doing a little somersault. And then to provide an incredible view. You fly about 100 kilometers, which is about 10 times higher than you fly on a jet. You can see the curvature of the Earth, the thinness of the atmosphere. And it brings you safely back. But the real significance of New Shepard is not that it's a vehicle for space tourism, but the reason we developed it. And by the way, we developed it without any government funding. This is a completely private enterprise done by a US company, Blue Origin. We developed it in order to perfect the techniques of reusable rocketry. And we knew that because tourists would not pay a lot of money and wouldn't do it unless it was very safe and reliable, the space tourism business would allow us to perfect this technique. And so New Shepard is known for being the first rocket in history in 2015 to be reused, perfecting this technique of vertical powered landing. And now it has done it repeatedly, and not only has it done it repeatedly, but many companies, in particular SpaceX, are starting to follow along. SpaceX now has far rivaled Blue Origin in the frequency. Over 500 times now, they have reused the Falcon 9. And I'm sure you've heard they're developing a much bigger vehicle called the Starship. It is so big, it's the size of a building, of a skyscraper, coming down and being caught in a tower. It will reduce the cost of launching something to space by 100 times. It can land 100 tons on the moon. And Blue Origin is also developing a very big rocket. It will be the second biggest rocket in the world after Starship. It's called New Glenn. In fact, they have a launch, the second launch ever of the vehicle, planned this evening. So things are changing very quickly. So you saw that giant spike in launches when the launch prices went down by a factor of 10 because of reusability. When they go up by 100, what are we going to do with that? What are we going to do with that as a civilization? Well, here are some ideas, and really, the main thing I want to focus on is that what we're going to do with that is really up to you. It's not really up to me. I mean, we are developing some technologies that I'll talk about, but it's really up to you and the ideas that you have that will determine what we do with it. Some things that are happening, as Alice talked about, there are commercial stations. They're going to replace the International Space Station in a few years. Even today, there are so many satellites now in orbit that within a few years, every single one of you will be using a cell phone that will seamlessly switch between cell towers or satellite, and you won't even be aware of it. At some point, in fact, the Starship goal for how cheaply it will be to fly to space will enable data centers to be put in space. So data centers, especially to train AI, are currently one of the fastest growing uses of energy. And there is abundant energy in space. The sun shines all the time. We are very close to being in the place where it is economically feasible to put them in space and much more sustainable as well. And big companies are investing in this, like NVIDIA is part of this initiative. They are the biggest company in the world. And of course, there will still be and growing space tourism. In fact, I'm very confident that of all the 80% of you that answered that poll that said, would you go to space? I'm very confident within your lifetime, you will be able to. It will be affordable, and it will be for everybody. It won't be just for people that train for years. It will be like you can book a ticket and get on an aircraft, and what you will do there is really up to you. But the one use that I am working on personally, that my company is working on, that I want to focus the rest of the talk on is space resources. So the biggest problems on Earth are all stemming from the fact that we have very limited resources on Earth for our civilization. We are degrading the environment. We are using those resources at about 3 to 4 times greater than is sustainable. But the irony of that is that the solar system has an unimaginable wealth of resources, thousands to millions of times more resources in all different forms than we have on Earth. So it's like we are living on an island, and we've cut down almost all the trees, and we hardly grow things in the soil anymore. And yet when we look across the other side of the water around us, we see hundreds of islands that have just as much and more pristine resources than we have on our island, and we just have to get there. These resources include those of the moon. There are so many resources on the moon. I call it the 8th continent. Many people call it the 8th continent because it is made from the Earth. It was born out of the Earth billions of years ago. So it really has everything that you need for an industrial civilization. Metals, water, rare earth elements, which are essential for batteries and electronics, carbon, nitrogen for a breathable atmosphere. But there is one thing that I am particularly focused on. It is something that's very, very rare on Earth, and it's very valuable on Earth, and it is very abundant on the moon. And that is something called helium-3. So what is helium-3? Regular helium is helium-4. It's got 2 protons and 2 neutrons, so it has an atomic mass of 4. It's very common. Party balloons, you can buy helium very inexpensively today in large quantities. Helium-3, by contrast, has 1 fewer neutron, so it has an atomic mass of 3. It is very, very rare on Earth. It is so rare on Earth that the market price today is $20 million, or approximately 20 million euros per kilogram. And what is it used for, or why is it rare? The reason it's rare is it's produced in the sun, in the fusion reactions of the sun. So it's spewed out in all directions by the solar wind. It never reaches the Earth because the Earth has a magnetic field that deflects those ions away, so it never gets to the surface. But the moon doesn't have a significant magnetic field, so it's been collecting on the surface of the moon for billions of years. There is an estimated 1 million tons just in the first few meters of the moon. By contrast, 1 million tons, we currently in the world produce less than 10 kilograms per year of helium-3, and it costs a lot to make it. It's basically made in nuclear reactors. So what is it useful for? Well, it is essential for certain types of quantum computing. You might have heard about these computers that can solve these very complicated problems millions of times faster than regular computers. It is used in national security to detect whether someone's trying to smuggle a nuclear material across borders. Someday it will be used for fusion. There's enough, that 1 million tons is enough to power the Earth with clean energy, not producing radioactive waste for 10,000 years. And it is also used in certain types of medical imaging. So there is a huge market for it today if it were available in greater quantities. So I co-founded a company called Interlune to develop the techniques and exploit this market potential. So we have plenty of customers. We have validated that the demand is there. We've sold hundreds of millions of dollars of product. We just need to get it. What we will not do, and what we don't need to do, is develop the rockets or systems to large launch payloads to the moon. Primarily due to the US government and its international partners, there are already huge vehicles, like the Starship or the Blue Origin Mark II vehicle, that we will be able in about a few years to buy a large cargo launch to the moon. It's already happening. That image of the shadow, that was a private lunar lander that landed earlier this year. But what will it look like? What are the techniques for lunar helium-3 mining? Well, quite frankly, we don't quite know, and we didn't have a good idea until maybe a few years ago. So we worked with a company called Extend, which is here in the Czech Republic, to produce these artistic renditions of our concept. The idea is it is present on the surface of the moon, but it's very loosely held because it's just helium doesn't really like to bond with anything. It doesn't bond with anything. So it's just on the surface. We have these machines called harvesters. They are about the size of large cars. They will move across the surface, excavate the regolith, the lunar soil, and crush the material. Because it's so loosely held, the helium gas will come off just by crushing it, and then immediately return that material back into the pit. And we get this gas off. That gas contains helium-3. So with an assembly of about 5 of these vehicles in this picture, and this concept is about 1 kilometer in radius, as well as a central power station, we can accumulate this helium-3 gas and put it in pressure bottles. Those pressure bottles, over the course of a few months, and I'm not talking about very large bottles, one that I could hold about this big would contain about 5 kilograms, about 100 million euros of product. That's all we need to bring back. We will put them on small rockets, small capsules and small rockets, and launch them from the surface. It doesn't take a lot to get off the surface of the moon. The gravity is so low. If you can get away from the moon, it will just fall into the Earth in a few days. So that's the concept. We're doing more than just making pretty pictures. We are developing at Interlune the technologies to do this. One is lunar excavation. We have to dig through a lot of material in order to do this. And how do you do that on the moon? That is also another invention. So this machine is especially designed to perform excavation in low lunar gravity, which is about 1/6 of normal gravity. It does that by actually submerging the cutting head below the ground, so the material that's above it can keep the wheels on the ground. Another thing we do all the time is we use the US version of the zero-G aircraft that Alice talked about to do all of our development that involves crushing or isotopic separation. So we've now flown on this aircraft many times, including myself, and it does take a little getting used to. In this astronaut training, they dive fast enough so you get 0 gravity. But if you dive a little bit slower, you can simulate any gravity between 0 and 1, but you can simulate lunar gravity. And it is a lot of fun. If it looks like a lot of fun, it is a lot of fun for about the first 20 parabolas, and then you just want to vomit. So maybe not Alice, I'm sure he did fine. So we use these techniques to simulate lunar gravity. We have many other ways to simulate the processes that we need on the moon. But ultimately, we need to go there to really develop this technology. So we are going there. Oops. The clicker is not working here, guys. Oops. We are going there. Let's see. Can you play that? OK. I'll just talk through it. So we have partnered with a company called Astrolab and Astrobotic to design, and as well as NASA, to deploy a camera, a multispectral camera, a special instrument to the surface of the moon. And this is a method to detect the presence of helium-3 because it's not really evenly distributed across the moon. There are areas of high concentration and areas of very low concentration. So we want to go to the places where it is very abundant. We have delivered the instrument. It's getting integrated onto this rover called the FLIP rover, and it is scheduled to launch in July of next year. So one thing I want to close with you about is I've been talking a lot about what we're doing, and one sort of use of this low-cost space launch, but how is it relevant for you? I mean, one of the reasons I wanted to come here to Prague, to Europe, is that although there is a lot of development happening in the United States as well as China, there is also a lot of development happening in Europe and other countries. These are some examples of the programs and rockets and capsules that are being developed in Europe or other countries like by Rocket Lab in New Zealand. So if this does interest you, whether or not you want to be a scientist or an engineer or a business person or a lawyer, or just in communications, this is something you can definitely be involved in. And it's something that we need, quite frankly, the world needs you to be involved in. It needs your energy. I'm as optimistic about the potential for the development of all these technologies in this future that will occur in Europe as I am in the United States. So if you have any more interest, you can go to interlune.space to learn at least about what we're doing. Otherwise, thank you very much for your time.